Charging these two towers has caused us so much problems. You want to know the problem? Let's get into it. Welcome to jwsolarusa. These power walls, twin towers, 17.088 kilowatt twin tower lithium ion energy storage Volkswagen e-Golf has caused us nothing but headache to charge 1200 amp hours. This is what happened. You want to hear the story? Right here. These machines cannot keep up to charge these twin towers. You know why? Because the amperage is too much to charge these guys. They are sitting on parallel at 12 volt. Because of that, the inverters are overheating. It shut off yesterday. Been charging from 2150 hours, which is 9:50 Central Standard Time right here in Minnesota, and woke up in the morning. It's acting like it's fully charged. We're still sitting at 14 volt. We struggle so hard with a 14 volt. This batteries, the voltage is not going up at all. That's the difference when you go with a higher voltage battery bank. The voltage rises really quick. But at a low amperage, what I've learned from this experiment with these twin towers here, nothing but a headache. It's the second day we're charging this thing, and the time is now right there at night. So what I've came to do, I shut the system, went to work because I don't want anything to happen behind me. And as soon as I came back at 1900 hours, then I fired up the system, and I decided to put a little fan right here that pulls only about 0.25 amps at 120 volts, 110, 115. I have to put a fan to cool down. The transformer is here, and I think they have a capacitors or resistors. We can get right there. I'll show you guys. This thing was hot yesterday. It was really hot. Heat coming out from these was really scary. So what I've done, I decided to put a fan right here, targeting the main transformer right here to cool it off. So let's check the specs here. Pushing the tech button, okay, and select temperature. That's the battery sensor, but those sensor hook up to this. Okay, so dial this thing. That's the transformer right there. It's 231. I've seen this thing went about 200, I think 244 or some 200 and something, 60 something. It was hot. And this one, which are the transistors, were okay, these are the transistors that went, I think 200 and something volt or something like that. The transformer is just hot. So these are the things that let this inverter, that's why I decided to make this video, super safe, sturdy, powerful, just a little inverter, which is a 12 volts, a kilowatt, and it takes only 20 amps from the grid to charge, and 15 amps out, just like your regular outlet at your house, and it's built-in inverter charger. These are the results. Why you have to buy high quality machines. It protects itself. It senses the trouble. It senses too much stress, temperature. It said, I'm not gonna destroy myself, or self-destruction, or causing problems for my owner. I will shut myself off. And that's what he did. And this morning, tried it, came to over temperature. So the red lights came, fault. It says over temperature. It's shut off. This is what you need. This is the reason why a lot of people, or a lot of us, are buying very high quality stuff and very expensive. They might be small, but they're expensive. Okay? I'd rather say you can buy whatever you want to buy, but make up your mind. Not for cheap. Don't buy things for now. Just because, oh yeah, it's going to be, I'm going to change it. It's going to go off or blow, or it's going to just stop working the time you need it most. Here's the reason I have machines like this on my board. This is the reason why I have stuff like that on my board. Some people say you're paying for the name brand. They might be right. But that name brand comes with a reputation. This name brand came with a reputation. This name brand comes with a reputation. And even the little guy right there. So anything in life you want to do, sometimes look, when someone said the experience, when employers trying to hire you, they say we want to hire this person not for the education they have, but the experience you've done with all your education. Have you done some tests? Have you done something, some amazing stuff in your life, or whatever? What have you flipped over to make money, or especially for business? They want to see someone who can just do it on a risky time. Well, these machines have proved themselves. These guys have proven themselves. The wires are cold to the touch. And this guy is not throwing a lot of amperage, but is charging these batteries fantastically. They're absorbing the power they needed. And they're soaking in with all the good stuff, with all the good work that JW Solar and hard work they already put into this. And they are cool to the touch. And that comes again. Doesn't mean when you have good things, expensive things, you don't take care of them. That's why I decided to make the feet right here. You see what happened now? Overheating. That caused the system shutting off. And you don't want to do anything, any destruction to the system. I suspended this. Oh my God, this is really cold. Just like when you left something outside in your car in the winter time. That's how cold they are. Cold to the touch. Because it's not a lot of power thrown into them, but the thing is they are ventilated. And we come back here. Learn from me, okay? This is not any politics or no jinxing or anything. Learn from me. I like to do experimental stuff. All my videos, if you want to pay attention to my videos, this is what I do. Some people probably don't find them fascinating. They want a fast, happy-go-lucky, very quick. They like quick fix. The quick fix can get you. Do the right thing. The right thing takes time. I'm showing you all the feet I've made. And if you haven't seen this, go back to the video and see the first one. Follow the series. Follow the series. You see how I came up with this, why I'm doing this, and all my machines are all suspended. I suspend them. All the install I've done for my clients, everything is suspended with bushings for them to breathe good. This guy here has a back plate. You see, it's suspended, the inverter and the back plate. See, this guy here is suspended with the legs. You see, there's a ventilation on the back, though the inverter is not sitting there. But the metal is absorbing the heat to this. It needs to, dissipate heat. So, just want to show you guys. This is the voltage we're charging on. I'm gonna let this guy run till morning, few hours from now. About 32 minutes, it's gonna be another day. We start another day, so it's gonna be 0 hours. So let's see. We have to put about 9 millivolts. 9 millivolts. So we are seeing 15.9. So the batteries are set at 16. So let's see if we can take them all the way there. It's gonna be a while, but it's okay. Charging slowly is beneficial and useful and healthy for the batteries as well. Some of them can take quick charge, some don't. Here, it's a little bit warm here. On the other side here, the fan is penetrating here. It's cooler. The heat coming out here is hot. I would have used a temperature gun, but it's getting too late. I don't want to get this video too long. But I want to show you the importance about venting your machines. And speaking about it, before I forgot, it's a good illustration. See how I suspended all my machines, how I lift them up with bushings. It's there, it's here. So I'm not just, I don't talk the talk, I do the do. So see, all the bushings, they're all suspended. Could you imagine if this thing would have been screwed directly to the board, how hot that board would have been at a very high temperature or climatic condition. It's really hot, like summertime. It would be a disaster. It will probably get on flames, God forbid, because the heat, that board probably would have been really baked with heat, and it's gonna be all flaky. And by doing so, cooling the system, you keep the amps working, because efficiency, resistance goes by heat, and heat destroy anything. Heat is not anything good. It destroys, makes you, for human, makes you uncomfortable. If you want to sleep, you want to get it really cozy, just like the room or temperature that makes you sleep better when it's cooler. But when it's too hot, you can't sleep well. It's too cold, yeah, you can put on more clothes or eat more, get you warmer. Or heat is not, there is no way you can compromise with heat. It's just discomfort. That's the same thing electronics and machines are all suffering from. Heat is not a good deal. Well, it's good for other people that loves it and love it and love it. Well, when it comes to electronics, I'm just telling you this to be honest with you. Don't treat the electronics, if you like heat, they think they're supposed to take it because you like the heat. If you don't like the cold, make it possible for the machines to work better, instead of trying to treat the machines just like because you love the cold, the hot weather, and they're supposed to suck into that. No, it doesn't work that way. They die. You kill them. The lifespan goes down. The life expectancy of the batteries gone, because you're supposed to keep batteries at 25 degrees C. That's just the rule of thumb. 25 degrees C, which is a 76 degrees Fahrenheit. So don't you just treat them just like anything. You pour a lot of money. There's a lot of money here. And you guys heard I already mentioned how many times some of these things, how much they cost. Just one brick right here. one module, this one. That's why do you think they built like this? It's aluminum to dissipate heat. They can get warm really quick, they can get cool really quick, and they can get cold or freeze really quick because aluminum. So that's what I'm saying. They make them to dissipate the heat, they make them to be cooler really quick, and to stay on a normal temperature. You don't want to bake them, you don't want to cook them, you want them to be happy, you want to make them comfortable. This is the message I have for you today. Heat is a great factor, is the enemy to electronics, to life, to plants, a lot of stuff. Heat is not good, but this is the safety we have to do. You can do all big wiring, you can do all the resizing. Why we do that? So that we can stop heat, so we can prevent heat. Because these ones, if the wire is smaller, like right now we pumping that kind of power, it would have been dead. Okay, that wire would have been burnt because of heat. Can't handle it. So just want to let you guys know how heat is a great factor towards electronics, in life, in real life, on a lot of things. So these machines are doing the best to keep up so that they can fill up these batteries as I wanted them. It's gonna take a long time to take a lot of power from the grid to do this. I want to do it not in a fast way. I would have logged them into this, tie them in a series, then these guys would have been charged already. I want to give them a slow charge. That's why I use these guys here to charge these guys, and they will last longer. I want them to soak in with all the power, not the surface. They get into a bulk mode and charge them really good, and put something and break all those kind of things that probably they never went through, instead of a surface charge, and they get in pretty well and charge them equally. Voltage comes equally, and after they're all done finish charging, then I can series them, and now we can run the entire modules on the same voltage. Remember, this was the tower 1, this is tower 2. This one came later. I've known this guy for what, over 2 years approximately, and this guy, I have no idea about him. So the years are all the same, but this one has a 2016 and 2014, 15 on them. So these are straight 2014s. So I just want to make sure that these guys get along pretty well, and they're gonna age well. But if the opportunity comes again, I can able to see these guys cheaper, or I can afford, what else will happen? I'll buy another stack of these guys again. I will do it again in a heartbeat. So that time, these are the only guys gonna be my batteries I'm gonna deal with. If I have the opportunity to get a car that's already wrecked, I will take the entire batteries and just probably scrap the entire part on them just for the batteries. That's how good these batteries are. I've never seen videos on it. I've seen the manufacturer, how they manufacture them, but and how they disassemble one of them to the factory. But I've never seen anybody else like me talking about these batteries. There might be some people that own them because it's like a race, a competition, but probably they're watching my videos, but they are not making videos on them. But anyway, if that be the case, if you have these batteries, you make videos, let me know. Let me see what you have or what you have to say. If our experience are all the same, then we can be in the e-golf family. All right, make some videos, show people. Maybe yours are working well, better than mine, or maybe mine are working better. We never know. Well, just this chit chat thing and talking about heat, efficiency, resistance, and all that stuff. Live from Minnesota, jwsolarusa, USA. Thanks for watching and good night. I wish you well with your solar project. May the solar be with you. And continue to do the right thing. We're on the right track. The future is right here. Storing energy for night. I would love to get this one all the way charged. Maybe fired up those 2 inverters and run them all the way to see how they can handle on the 12 volts. And after that, I can transition them to the 24 volts and transition them to the other system and transition them to that 48 volts, because this is the reason why I have 16 modules of this, because I can able to do anything I want to, and they're configurable, they're user friendly, and all the good stuff you want to do. These batteries can let you do that. So that's why I'm trying to stick with the same batteries. If I have the chance, I have the LG Chem on the box that are strictly 48. So this one is strictly 12 volts. I can do 24 something all the way. Okay. All right. Bye for now. I think it's enough. Word for wise is sufficient. Like and subscribe. Stay tuned and see how the e-golf gonna be working with the board right there in full power after they got all done charged. Let me show you the meter one more time. Progress 15.2. Good night. Eight. Eight. Two 2016s. Two 2016. 14. Almost completed to be charged. We are hitting the 16 volt. It's only 2 millivolts remaining for the 16 volts for both towers to be completely charged. Like and subscribe. jwsolarusa USA. Here are the towers. We are charging 17.088 kilowatt hour lithium power wall, which is 1200 amp hours of current, and here is the wattage, 17.088 kilowatt hours. These are how the batteries are connected and in parallel, and we pretty soon we're going to be switching, removing this. Now it's flashing, telling us that it's 1 more millivolt. 15.9 started flashing. We're getting there soon. And we're going to untie these ones and wire them into series now. 12 volts here, 12 volts here. We just have to use one wire coming from, maybe I will try to use one of these Nissan Leaf orange wire, the high voltage wires, or something bigger than that to do the series here and get it connected from the bottom there to one of them here when I flip this one to the back. So give us the positive here and the negative here, and we have the series configuration for 24 volts. Like and subscribe. jwsolarusa in Minnesota from the command center. Bye for now. As we wrapping up charging up these batteries, these Twin Towers power wall from JW Solar USA command center in Minnesota, guys, this is what I have for you. And we're sitting at 15.9 volt, and we are putting in 21 amps because the voltage is higher now. The amps are dropping, and we are ready for business. Pretty soon this battery is gonna be they're balanced, and they're gonna be all charged at equal voltage, amperage, and capacity, or kilowatts, whatever you want to call it now. And we are almost done. And this battery is going to be fully powered, compressed, or pressurized, any word you can use to make this battery a success. And this is what we have done, and we've done our best to get these batteries and to go through the process and show you guys everything what I've done here at the command center of the JW Solar USA. And we're gonna be putting these batteries to work pretty soon. Trust me, we're gonna put them to work and see how they're gonna perform. And we're gonna do a load test. We're gonna do a lot of tests, and how many days this battery is gonna be running without being tied into solar, neither being charged at all on the grid or off grid. So guys, it's dropping to 20 amps, and pretty much it's gonna go to 0, and these batteries are all charged. I'm gonna let them sit. Remember the voltage there, maybe 1 day or 2 days or a few hours. We're gonna put the probes there and check them if the voltage drop or no drop, maybe 2 days or 1 day or 2 days, and see if we still maintain the voltage. And from there we're gonna connect them. You want the batteries to rest, okay? They've been taking a lot of heat the past days charging, and even the inverter is gonna have a rest. I have this fan, is doing a fantastic job. It just cooled the transformer. Now let's check the temperature again on these ones, so you guys can see how cool it is to have machines that can tell you everything. The transformer dropped. If you look at it, rewind the video, see transformer heat drop temperature to 140, and the transistors are 111 because it's less amps coming in now. To charge the batteries, so it's not like stress on the transformer. It's not demanding any more power conversion, and everything seems to be cool. Like and subscribe. JW Solar USA live from Minnesota. Love you guys all, and stay tuned And thanks for being part of these series videos. And catch you back later in the next video. So stay tuned for more to come, how we're going to be doing all the testing and everything. And you can rate these batteries, because I already have my reading for them anyway. Bye for now.